Welcome to SAT Saturdays. On Saturdays and maybe on Sundays, I'm going to do 3 SAT prep problems for you all to work on. So, the first question tells us that the average of several exam scores is 80, and one makeup exam was given, which brought the average up to 84. If the makeup exam score was a 92, how many exams were taken? Okay, so let's go ahead and set up the equations that relate to this problem. So first, we know that 80 was the initial average, and we'll call the total score TS, and the number of exams originally taken N. So that's our average, our total score, so all the scores added up, and then N, the number of tests that were taken originally. And then our new average is 84, and we know that that is equal to total score plus 92 over n plus 1. And that's because we're adding our total score plus the new 92 that the makeup exam scored, divided by the number of exams previously taken plus the one makeup exam. But now we have two equations and two unknowns. We have our total score and we have our number. So what I'm going to do is I'm going to go ahead and readjust this top equation to solve for total score. So we're going to multiply both sides by n. So this n cancels with this n. That leaves us with TS equals 80n. So I'll go ahead and write that down. We're going to do the same multiplication here. So we're going to multiply by n plus 1 here and n plus 1 over here. So this cancels with this. And that gives us 84 times n plus 1 is equal to, we're going to plug this equation in for TS here. So we have 80n plus 92. And that's just from plugging 80n for TS there. Then we'll go ahead and multiply this out. So we get 84n plus 84 is equal to 80n plus 92. And now subtracting both sides by 80n, and then also subtracting both sides by 84. So we do 84n minus 80n, that gives us 4n here. Positive 84 minus 84, that gives us 0. So we have 4n is equal to 80n minus 80n, that's 0. 92 minus 84, that's 8. And now we have 4n equals 8, divide both sides by 4, and we get that n is equal to 2. So now that we know that n equals 2, the total amount of exams taken was 3. Because remember, n was our number of exams that were taken originally. So we have 2 plus 1, which is 3. So total exams is equal to 3. And that's the solution to our first problem. Let's go on to our second one. Okay, so our second problem tells us the midpoints of a square are connected to make a new inscribed square. And it asks us to find the ratio between the areas of the outer and the inner squares. So let's go ahead and draw a picture of our square here. And I'm going to go ahead and give the square side length 2. This will work for any side length that you choose, but I'm going to use the simplest one, which is 2 here. You could also use 1, you could use 6, whatever you want, but I'm using this because it's going to be easily divisible by 2, because we're looking at our midpoints here. And we're going to connect these to make a diamond shape in the middle of our square. And that's going to have an area that we're going to compare. So first, we need to know the side length of this inner square. Well, we know that this leg here of this right triangle is 1. We know that this leg is 1, which means by a squared plus b squared equals c squared, if 1 squared plus 1 squared equals c squared, we know that c squared is equal to 2, and that c is equal to the square root of 2. So this side length here is the square root of 2. But now we can find the areas of both. The area of the outer square is going to be equal to 2 squared, because that's our whole side length squared, and that's going to be equal to 4. And the area of the inner square is going to be equal to the square root of 2 squared, and that's equal to 2. And to find the ratio between the two, we simply divide. So we have 4 over 2, which is 2. So that is our final answer for this problem. Let's move on to the last one. Okay, so here we have our last problem of the day. And it tells us the radius of circle B is 3/4 the radius of circle A, and that the distance from the center of circle A to the circumference of circle B is 3, and the reverse distance, the distance from the center of circle B to the circumference of circle A, is 2. And it asks us to find the area of circle B. I'm going to go ahead and put the picture from the problem right up here in the corner so we don't have to draw it out. So let's go ahead and start this. So we know that the radius of circle B is equal to 3/4 the radius of circle A. And that's given to us in the problem. And then from that figure, we can see that with this fact here, that the center of A to the circumference of B is 3, we know that the radius of A is equal to 3 plus this distance x here up in the picture. And similarly, the radius of circle B is equal to 2 plus x from the picture. But now we can substitute both of these back into our top equation. So we get 2 plus x is equal to 3/4 times x plus 3. Okay. And then multiplying this out, we get x plus 2 is equal to 3/4x plus 9/4. That's just by multiplying 3/4 times x and then 3/4 times 3. And now subtracting both sides by 3/4 x, we get 1/4 x plus 2 is equal to 9/4. And then subtracting 2, we get 1/4 x equals 1/4, because 2 is equal to 8/4, and 9/4 minus 8/4 is 1/4. And now pretty easily, multiplying both sides by 4, we get that x is equal to 1. But we know that if x is equal to 1, the radius of circle B is equal to 3. And from there we can find the area pretty easily, because we know that the area of a circle is equal to pi r squared. And we know that r is 3, so that means that this is just going to be 9 pi, because 3 squared is 9. So our area here of circle B is 9 pi. And I think that's enough for now.